you, Janko. Good morning.
Oh, hi. How are you? Everything okay?
I'm doing great. Thank you so much.
Very welcome. I'm glad that you are with us. I really appreciate.
Same here. Happy that you invited me.
Okay, good. So as I told our audience, you are really a great security evangelist working for Juniper, our dear partner, and I would kindly ask you to proceed with your interesting lecture.
Thank you so much. Thanks. And I'd like to welcome everyone to my session and start by acknowledging more than 20 years of partnership between Juniper Networks and Smartcom. Together, we delivered innovative solutions to our customers, and we would really like to thank you for this partnership, and we appreciate that so much.
Yes, it's vice versa, Aviram. So go ahead. Thank you.
Great, thanks. So the topic of my presentation is cyber threat intelligence sharing, and I'd like to show you how it could be implemented as part of our connected security approach to drive security operations excellence, to increase the efficiency and efficacy of your SOC teams. So let me start with the description of the problem, share with you some terminology, and only then I will talk to you about what we can do at Juniper. So this is the main idea. We would like to utilize crowd wisdom as a concept for cyber defense. It means that we will collect different pieces of information from many sources. It could be third-party sources, it could be other analysts, it could be other locations in the network, and we will utilize those information objects to improve our cyber defense posture. And if you think about this conceptually, you will see that there are two perspectives. One is all about the target. It means your applications, your hosts, your operating systems, and we usually share vulnerabilities about those targets. There are many companies active in this domain, but we at Juniper are focused on the other one, and this is the attacker perspective. So in this domain, we share pieces of intelligence about the way the attackers behave. It could be fingerprints of files, malicious files. It could be TTPs, tactics, techniques, and procedures, the way they behave. So when those objects are shared, there's a great benefit to all sharing parties. A bit more details about this cyber threat intelligence concept and objects. In essence, it is just a data object. It contains a description of an emerging or an existing threat. And the main characteristics, the most important one of this data object, it should contain an actionable advice. It means that the receiving party of that information will be able to do something with it. Block, contain, mitigate. If you think about the sharing possibilities, you will find out that there are many ways to do it. It could be done manually or automatically. It could be done between organizations or within the same network in the same organization premises. We call those objects in Juniper terminology security intelligence or SecIntel. So whenever you see on my slide SecIntel, it means CTI objects. If we look at the way we can describe those objects, again, there are many ways to do so. It could be structured or unstructured. For example, a blog post would be an unstructured way to share intelligence. A structure would be maybe following the cyber kill chain the way it should be done. It could be based on code or text. So again, if it's between machines, it's most probably going to be code. And if the target is people or machines, obviously the sharing method is different. So that was about CTI. I'd like to take you now and speak about the problem domain. So what is the problem with the SOC analyst? What are they facing? And the point here is that within this large incident response life cycle process that they would like or they need to follow, there is a subset which is called detection and containment. And we would like to focus on that subset of the whole process and improve it, basically move from a state of mind of incident response, something happened, let's respond, into a different state of mind, which means there is an automative system that continuously responds to threats or events or incidents. So if you think about it, we have three components to that aspect of detection and containment. So the first one is the prevention piece, maybe a next gen firewall or IPS or a legacy antivirus product. It sits in line, it will block immediately if it sees something bad. But modern malware or modern threats are more evasive. It takes more time to detect them. So we can't just rely on real-time prevention mechanisms. We need to add another layer of detection. And that layer should work all the time. And once something is identified, generate a response. And that is the whole secret of this new terminology that you might have heard of called XDR. So you will see that the analysts and the industry is talking more and more about extended detection and response. And this is all about this trend. In a way, this is what we do with connected security, and I'll get to that later. So moving back to the way we share CTI objects, we would like to take a detection in one place and transform it into a prevention in another place. So not only respond to a specific detection, but also make sure the same thing doesn't happen again in another place. And to do that, we need three components. So this is a generic architecture of a CTI sharing workflow of operation. The first component is the source of the feed. So I'm not going to discuss how we collect those pieces of intelligence. I'll get to that a bit later. But the threat intelligence feed is the source. The destination is either a policy enforcement point, which means a product that will stop bad traffic, or a decision point, which means it could be kind of a management or incident management platform that will use that feed correlated with other things, maybe. So these are the two important components. Now there's the third one called threat intelligence platform, TIP. And this is all about consolidating different feeds, adding context, and possibly pushing all this into the enforcement points. So this is these are the concepts behind threat intelligence sharing and why it's beneficial for SOC operations. Let me move now and start the discussion about connected security, and I will follow with some more examples. So what is connected security? This is our overall concept that brings together visibility and policy across multiple domains. It includes the users, the applications, the devices, and also the infrastructure. And the idea is to create an end-to-end policy and visibility from endpoint to edge and every cloud in between. The end goal would be to create what we call a threat-aware network. And I will show you in practice what it means in the next slide. So this is a threat-aware network. It ties the intelligence I talked about earlier, the CTI objects, into the infrastructure in a way consolidates the security with the networking devices. So this is what we do at Juniper. We have a source of intelligence called SecIntel Everywhere, or SecIntel. It comes from two products that we deliver. One of them is in the cloud, and it's called ATP Cloud. The other one could be on customer premises, and it's called ATP appliance. Now, those products are similar. They are our advanced anti-malware solutions, but they also include the feeds. And we get the feeds from many sources. One of the main ones is our Juniper Threat Labs team. So this is the research team that puts together those feeds based on what they see in the wild, because we have a network of honeypots deployed all over, based on relationships that they have with organizational entities, with other vendors, as part of alliances such as the Cyber Threat Alliance, etc. So there are many sources to this feed. What we eventually do with this is we push it into our products. So we're talking about the infrastructure, the networking products. If I take the SRX firewalls as an example, it's natural for the SRX firewalls to get feeds from secondary feeds and block command and control traffic. That means any communication from your network towards a malicious server, to block access to malicious URLs, to block access to malicious IPs, to block Tor traffic if you want to block or to allow specifically different types of communications, etc. But then we can also push it into devices which are not security in essence, for example, into the switching. So EX and QFX switches, as well as the missed access points, can receive a feed that we called infected hosts. And what it really means is that when we identify by our mechanisms of advanced malware detection that there is a host, a device, IoT device, Windows workstation, doesn't matter, that is infected, we know that because of the traffic that flows through the network. Then what we can do is we can contain that device and block it on the layer 2 level. So this integration with the EX switches and QFX switches exists today. With the missed access points, it's coming very shortly. Then we can also utilize that to block any command and control traffic outside your organization going through the MX routers. If you put a router like that on the edge of your network, that could also be blocked there. So in general, we move that intelligence as needed between objects or between devices, networking devices, and also we are able to consolidate intelligence from third-party sources. And I will show you an example a bit later. This is the complete portfolio, basically putting together, as I mentioned, any cloud, any campus, branch, and remote office device, any data center, any one infrastructure, any wired and wireless access points and switches, adding the security layers, layer 4 detection, feeding them with SecIntel, and managing everything from a single point. We have components such as the security director, and that's the management system of Juniper that includes a window into the advanced threat prevention product in the cloud. It includes the tip functionality I mentioned earlier, etc. So I know it was a bit theoretical, so it's time for a use case to show you how it is done in practice. And I chose, for the limited time that we have, to discuss 3 use cases. Now, the important thing about this slide is that if you go to our connected security page on the Juniper public website, you will find many other use cases. So those 3 that I would like to discuss are all about understanding who and what is on the network. I will start with what we call adaptive threat profiling. So this is contextual information. I will move on to discuss risk-based access control and show integration with third-party products. And I will finalize with the newly announced Juniper Secure Connect client that completes our endpoint to cloud story. So first thing first, we'll start with adaptive threat profiling. And this is all about the organizational context. So there's a saying in the security world, context is king. Context is really important. And the idea behind this solution, which is implemented by putting SRX devices and the Juniper ATP cloud advanced anti-malware technology I mentioned. The idea behind this solution is that we allow the intelligence generated by the organization to really circle back to other locations in the same organizations. In a way, intelligence from one defense for all. So this is how it works. We are going to feed from Juniper ATP Cloud the intelligence into the SRX devices. But say that in one SRX, and you can see that one on the left, bottom left side, an SRX event has been generated. And maybe that event shows an attack coming from one of your internal IPs. Maybe it's even a server. What we actually do is we share that piece of intelligence with the ATP cloud. In the ATP cloud, we can track and correlate the behavior of that specific IP address across all the network. And if we see fit based on the policy that we put there in advance, it will become a part of a pre-configured, specifically tailored SecIntel feed for your own organization. And it will be fed back only to your SRXs. So this is not about sharing intelligence with all the world. This is all about sharing unique intelligence coming from your organization to devices inside your organization. Something happened in the campus, we prevent the same thing from happening in all the branches, for example. So this is really about reducing the time to identify and block the customer-specific outbreaks. And this is the importance of this solution. Next example is all about, again, context, but this time integrating intelligence coming from a third party. So what you can see in this example is a company called WoodCloud. They have a cloud solution, but based on on-prem sensor, network sensor. They put it in your premises. They can see the traffic because it's mirrored to that sensor, and they can fingerprint and profile the IoT devices in the network. So the IoT is a big problem today. IoT devices are a big problem today. In many cases, they run outdated software. Many cases, they cannot or they don't have a footprint to hold endpoint security products on them. So they are in the loose. Many times they have default username and passwords. They are easily hacked. So what we can do here is integrate the intelligence coming from WoodCloud about the profiles of the IoT devices with the intelligence that we have, Juniper, as part of the ATP cloud, because we can see incidents coming from those devices. And together, we can make smart decisions, risk-based decisions. And the enforcement of those decisions will be through the Mist cloud. So the Mist cloud is all about how we manage our access points and also our switches. Today, this capability in Juniper can also manage the wired switches. So what you see on the upper side of this slide are all cloud solutions. The integration was done in the cloud between the products, not on your premises, but the overall story is that we can identify who are the connecting devices. We can detect any malicious activity coming from those devices, correlate that into a risk-based solution, or decision, and push that through the Mist cloud into the network so we can contain any malicious activity there. So we've reached the last example I have today. And as I mentioned, it's all about secure connectivity from client to cloud with our newly announced Juniper Remote Secure, Juniper Secure Connect Remote VPN. So this was a long-awaited capability. It was in practice released last week, and we have a client, VPN client, running on Windows, on Mac OS, on Android, and in the future on iOS. So 3 of them are released already. It will support and it supports IPsec VPN with a fallback to SSL VPN with a very granular configuration. So it will allow you to differentiate between groups of users based on URL or user categories. It was built with user experience-led thinking in mind, so it's very intuitive. And the way we implement that is just an add-on license on our SRX firewalls. So whether it's physical or virtual firewall, you can add a license, just download the client, and the client doesn't cost anything. The license is on the SRX next-gen firewall device, and you can build your remote access capability with that. So just to conclude, the idea of this session was to show how automating intelligence sharing can drive the security operations excellence. So moving those objects of intelligence about the attacker's behavior can be very beneficial. The point where it is beneficial is a subset of the incident response lifecycle called detection and containment. This is the subset. And it is really beneficial for 2 things. One is reducing the dwell time of attacks in your network. Dwell time is the time that the attack resides on your network and you don't know about it. And the second is reducing the alert fatigue of the SOC teams. So the SOC teams are overwhelmed with alerts. They have to deal with a lot. If we can automate a large percentage of the activities they need to do, because it's going to be obvious, clear what should be done if a certain policy is hit, then they will have more time to handle the more complex, the corner cases, the things that require a human analyst to analyze. So with that, I think I'm right on time, and I would like to thank you so much for listening to my talk. And